All right, so 5.3, our last section in regards to multiplying binomials and polynomials. We're going to be dealing with special products of binomials, which for the most part isn't going to be that much different than what you've seen in 5.2. The big thing we have to pay attention to is we have 2x plus 3 squared. Now, one of the differences we'll see here, and a lot of us who did the 5.2 extra worksheet saw when we have this squared here, the mistake a lot of students do is they want to distribute it in and they get 4x squared plus 9, but that doesn't work because what that squared actually means is we have 2 of that term, so it's really 2x plus 3 times 2x plus 3. So then we need to distribute that out. So 2x times 2x is a 4x squared. 2x times 3 is 6x. And then we go 3 times 2x is 6x. And 3 times 3 is 9. Add our like terms, and that gives us 4x squared. We have two 6x's here, so that's 12x, and then we have a plus 9 there. So as you look at number 2, same deal. That becomes 2x minus 3 times 2x minus 3 because it's squared. And then we distribute. So 2x times 2x is 4x squared. 2x times negative 3 is a negative 6x. And then a negative 6x, and then a positive 9. Combine our like terms, and we get 4x squared minus 12x plus 9. Now notice in those, both of those were initially kind of set up about the same. Our answers, the numbers are exactly the same, but the big difference is that's positive and that one is negative. Well, if we look at that one's negative and that one's positive, so just something to pay attention to. But the most unique one and important to pay attention to is this number 3 here. So same numbers, we have 2x and 3's, but let's see how this works out here. 2x times 2x is 4x squared. 2x times 3 is 6x. Negative 3x times 2x is a negative 6x. And negative 3 times 3 is a negative 9. And so from there, I get 4x squared. Now here, I get 6x and a negative 6x, so that is 0. And that middle term drops out. So that one there is going to be hugely important down the road. If you forget that middle term drop out, it's not the end of the world because you distribute out and it'll combine. But when we start into our next module, that will be helpful to remember how this then looks. All right, so let's do a couple more examples here. So as we look at this one here, that's x plus 4 times x plus 4. So distribute x times x is x squared plus 4x, and then take that 4 and distribute it in. So we get 4x and then plus 16. So it gives us x squared plus 8x plus 16. Up here, just because we have two variables doesn't change anything. That is 3x plus 2y times 3x plus 2y. Distribute 3x times 3x is 9x squared. 3x times 2y, 3 times 2 is 6. And then x and y aren't the same, so we don't add those exponents, so we just get 6xy. 2y times 3x is a 6xy. I keep it the same, even though the y is in front here. Keep it the same because those end up being like terms. And then 2y times 2y becomes 4y squared. There's our like terms. So we get 9x squared plus 12xy plus 4y squared. Now multiplying with minus signs doesn't really change from what we did up here. Process is still the same. So this is still x minus 5. Distribute get x squared minus 10x plus 25 there. Same thing over here. We get 6x minus 1 twice. Distribute, and we get 36x squared. Combine our like terms. And there we go. All right, so this is the one that's most interesting because we have those there. Now, some of you will get to the point where you just go, okay, that's plus, that's minus, everything else is the same, so I get x squared minus 36. If you don't see that, it's not a big deal. Distribute like you did, treat it like any problem you've always done. So that gives us x squared. That gives us negative 6x, then positive 6x, and then minus 36. Then when you can go to combine like terms, you see that those cancel out, and you get that same answer. All right, little extra work here. X squared times x squared. We add those exponents just like we've been doing to get the squared over here. 2 plus 2 is now 4. Then I go there and I get a negative 2x squared y. Here I get a positive 2x squared y, and then a minus 4y squared. So then I get x to the 4th. Those drop out, and we get minus 4y squared. All right, little word problem here. So a designer adds a border with a uniform width to a square rug. The original side length of the square rug is x minus 5 feet. The side length of the entire rug, including the original rug and the border, is x plus 5 feet. What is the area of the border? Evaluate the area of the border if x equals 10. All right, so we have our original rug. All right, so we got our square rug that had a length of x minus 5. Then we have our border that goes around it. Which is x plus 5. And we won't find the area of the border, so let's find the area of both. So this total rug here is x plus 5 by x plus 5. So we find the area by going x plus 5 times x plus 5. Which we work that out, we get x squared plus 10x plus 25. And then our issue there, then, as we move that off to the side there, we know that smaller portion is x minus 5, and then this is x minus 5. So we multiply that together, and that gives us x squared minus 10x plus 25. So that's our original rug. This one over here is the new bigger rug, and they just want the area of the border. And so what happens is we have this area that's inside there that we need to subtract out. So I have my bigger rug, which is x squared plus 10x plus 25. And I'm going to subtract this original portion here, which we had over here, as x squared minus 10x plus 25. Now, I made a mistake here. I'm subtracting currently just x squared, but remember we're subtracting the whole thing, so make sure we put our parentheses around that. I'm going to distribute that negative in, and that gives us x squared plus 10x plus 25. As I distribute, that becomes a negative x squared plus 10x minus 25. So as you combine like terms, there's an x squared and x squared. They actually cancel each other out. I have a 10x and a 10x, which gives me a 20x. And then I have positive 25 and a negative 25, and that drops each other out. So the total area of our border is 20x. Then they want us to evaluate it when x equals 10. So I substitute 10 in for x, and that gives me 200 feet squared. All right, so you have 3 problems there. I want you to do on your own. Again, like we did with 5.2, I'm going to call on a couple of you to share out. So you got 11, 12, and 13 to work on. Don't forget about your quizzes. And then give me an answer for your essential question.